Hey everybody, welcome to the Daily Space Weather. By the way, we forecast coronal mass ejections and we ask you, what's in your daily space weather? Is it the Smash News Network, least busted name in news? Or is it some other news source? Let us know in the comments. What's in your space weather? Here's what's currently going on in the northern hemisphere of the closest star. We've got a sunspot right in the Earth-facing zone here, sunspot 2833. A setting sunspot about to lose its name today, sunspot 2834, right over here by my epic pen. And this is actually two wavelengths here, 131 and 94 angstroms from the Solar Dynamics Observatory. Here's a full disk view in 193 angstroms. Massive coronal hole system associated with the North Pole there. You can see that dark region north of sunspot 2833. And part of the plasma filament associated with sunspot 2833 is obscuring the trailing end of this coronal hole. Actually, this whole region down here is a coronal hole. It's just not particularly visible from Earth at this point because of all the plasma in between us and it. Here's a composite view of the northern hemisphere. This is two wavelengths, 211 and 193 angstroms, to show the spectacular three-dimensional depth of that coronal hole. And you can see some of the filamentary plasma that I was just referring to. So some great views there. And when we forecast coronal mass ejections, we only talk about the ones that are in the Earth-facing vicinity. So let's take a look at the viewpoint from stereo A here, Lagrangian point 5. From stereo A, Earth would be off to your right if you were on the stereo A spacecraft. And here's a view from that, and you can see this large filament out here in the corona. That's grounds for a coronal mass ejection watch. Don't be surprised to see this eject, and we'll be keeping you posted on that if it should happen to do so. Here's one more view of sunspot 2833. This is 1700 angstroms, and this is just extreme UV. You can see it's remained quite stable here, quite similar to the size of planet Earth as well in the past 24 hours. And we hope you had a delightful spring. It's almost over. It ends tomorrow night at 11:32 and 9 seconds. We'll be streaming live for it. Here's where stuff is located in the solar system. And there's where things will be in 1 week. Looks like a full moon showing up in 6 days. And here's a star chart for all of you astrologers, astronomers, etc. I use in-the-sky.org. I draw in the ecliptic and I face mine to the south as I'm currently facing the south. If you're up before dawn, you may see Jupiter and Saturn and Mercury rising ahead of the sun. If you've got a clear horizon and low light pollution, Mercury's pretty dim, but there it is on the chart. The 10.7 centimeter radio flux at 77 solar flux units. Here's a 1-year chart of that. It's the black line that my pointer happens to be pointing at. The red line below it is the sunspot number. And we don't see any geomagnetic storm forecasts or anything like that on the Space Weather Enthusiast dashboard. That's the NOAA forecast. Pretty low levels of solar activity here. Again, if anything goes on, we'll keep you posted. And looking at global seismicity, we're really seeing an earthquake lull here. Once again, folks, we're seeing a drought of major earthquakes. So this is the year-to-date chart right here. And you can see we're currently in a drought here of 6.5 and larger magnitude earthquakes. So if you're in an earthquake-prone zone, please have a plan. Let's take a look at the rundown of earthquakes over the past 24. And we've seen quite a few 5-magnitude quakes, including this one in Algeria. So we're sorted by 4+ magnitude quakes. There is also a 5 in the Aleutian Islands near Sand Point. There are the 5+ magnitude quakes. Let's run down the list here on USGS. That 5.3 in near Sand Point, Alaska, occurred at 10:02 Universal Time yesterday on June 18th. There was also one by Cinnabung. It was a 4.6 magnitude. Deep quake near Fiji, over 540 kilometers estimated depth for that 4.5, then a 4.7 near Fiji, also at 453.8 kilometers estimated depth. Again, if you're in an earthquake-prone zone, folks, have an earthquake plan. Earthquake droughts, they end in earthquakes. Another deep quake there near Fiji, a 4.5 magnitude at over 600 kilometers estimated depth. So a series of deep quakes there. And here's a more shallow quake a little farther south between the Kermadec Islands and New Zealand, a 4.7 at 112 kilometers. Japan saw a deep quake as well. Continuing on. Calzone, rigatone, raviole, stromboli. That's actually the Stromboli volcano. That's actually Stromboli right there. It may not look like your calzone, but that is Stromboli. It's been erupting, and it's produced some new lava flows. Lava overspilled the northern crater area and formed a new flow on the upper Sciarra, about 200 meters long. And that's the incandescent light produced from molten magma turned lava. The difference between magma and lava, folks, is whether it's underground or not. Etna has also been erupting. Must have produced another paroxysm. Sustained lava fountains several hundred meters tall between 1:20 and 2:10 a.m. local time. Also a lava flow traveled from the southern crater toward the southwest. Violent lava fountaining episodes following each other at similar intervals, currently around 36 to 40 hours. A next event like this might well occur during the afternoon of today, Saturday, June 19th, if the pattern continues to repeat. Subanosejima in the Ryukyu Islands also exploding. Generating pyroclastic bombs. Please don't be the bridge between a pyroclastic bomb and the planet Earth. Ballistic impacts of volcanic bombs could affect area of about 1 kilometer distance diameter from the main crater. That's grounds to wear a hard hat. Kadavar, now back on the list here in the northeast of New Guinea, exploding. 5,000-foot ash plume there. Dakono on Halmahera, producing a 7,000-foot ash plume. Fuego in Guatemala, volcanic ash not observed in satellite. Don't assume it's not erupting. Revenador exploding in Ecuador, 14,000-foot ash plume there. Sabancaya exploding in Peru, 21,000-foot ash plume there. Flight level 120 over Nevados de Chilean in central Chile. It's exploding, producing a 12,000-foot ash plume. Grounds to remind our viewers not to pole vault the caldera. Please don't pole vault the caldera. It could be unfortunate. You may not have the skills of Steve Stimpak. Please do not pole vault the caldera. It could be unfortunate for your health. This public service message brought to you from smAsho.com. Next, looking at the GOES 16 sun-facing instruments. Here's the GOES X-ray flux. No solar flares of note over the past 3 days. It's flatline in terms of X-ray output. The closest star. No strikes in the proton flux either. No coronal mass ejections have been headed our way. We would have let you know if they would have been. And next, the GOES magnetometer. As we get into a series of quite in-depth magnetic data, there's the GOES magnetometer over the past 3 days. We're seeing some pretty sawtooth patterns here, and we're seeing some rather abrupt changes to solar magnetism. Let's get to it. Here's the top view ecliptic plane field plot, part of the Gong 2 data from the National Sunspot Observatory. And if you look over here between stereo A and Earth, you're going to see some abrupt changes happening right in this area. And to me, that's an indication there's probably a sunspot out by stereo A in the southern hemisphere. That's all I'll say. I don't spend a lot of time looking at stereo A, by the way. If you want to check that out, you can look at the Integrated Space Weather Analysis Center. And this is another great view here of these abrupt changes in the magnetism. To the east of planet Earth, you can see this sudden snap through of the South Pole-oriented current sheet shown in red. Anyway, that's the line of sight data. That's essentially the same data as this, just from a different perspective. And next, the line of sight coronal hole plot, and you can see this large trans-equatorial North Pole-oriented coronal hole here. Transequatorial coronal holes are the most geo-effective of all coronal holes, folks. The likelihood of those sending protons that cause some sort of geomagnetic unrest or geomagnetic storm is quite high, especially if that remains as defined as it looks. Not super defined, just a large coronal hole. And you can see some changes to the sun's B field here, also shown in blue. And let's take a look at the detected coronal holes and the detected sunspot groups. It looks like sunspot 2833 may have grown some opposite polarity umbrae here in the past 24 hours or so, as we're seeing it change to beta class there. So when the Earth-facing quiet expires here, which is happening today, we may see some increased solar flare activity. Again, the likelihood of coronal mass ejections is quite high. That's why we've stated that there is a coronal mass ejection watch. KP index, a measurement of global geomagnetism, currently at 1. Conditions are calm. And let's take a look at the real-time solar wind. And we have seen some anomalous data here over the past couple of days. You can see these error suspect down here. Those those yellow bars, those are a suspect. When we see the density drop below 1 proton per cubic centimeter, ACE and Discover aren't sure if they're seeing errors or correct data. Anyway, current conditions appear to be about 4 protons per cubic centimeter for the solar wind density, solar wind speed. Coming off of that coronal hole wind stream now, we see it subsiding in earnest. Current solar wind velocity, 478 kilometers per second. The rest of the factors here, the BT, BZ, phi angle, and temperature, are fairly uninteresting. Next, looking at 4 hours of data, magnetohydrodynamic pressure from the Space Weather Modeling Framework from University of Michigan. Since it refreshed, we'll let it play through, as we don't want to edit the video, so we can release it in a timely fashion. And you can see some reductions here in the pressure caused by reductions in the solar wind density and solar wind velocity. No real surprise there. There you can see those reductions in pressure coming in the past 4 hours. We show the data daily on the Daily Space Weather. And next, looking at ground magnetic perturbations, and we see some pulses here around this same period of time. Right at 7:30, you'll see a magnetic pulse happen there coming out of the western Pacific Ocean. And that's all got to do with that reduction in the solar wind speed. A reduction in induction caused a reflection of your magnetic function. Anyway, those are ground magnetic perturbations. Geospace delta B is referring to changes to Earth's B field. This one is in nanotesla. The last slide was in nanopascals. Nanotesla is the actual magnetic flux density. Nanopascals is magnetohydrodynamic pressure. Anyway, we let this play through a second time here as it refreshed. That's 4 hours of data. Geospace delta B. By the way, we do regularly stream live to Twitch. If you haven't checked us out there, download the mobile app. Twitch.tv/smashamash is the URL. Thanks to our subscribers, new and old, over at YouTube. YouTube.com/smashamash is where most of our content is located. Don't forget to press like and subscribe if you enjoy the content. Share with your friends, foes, science noobs, and science pros. We've probably got something for everybody. Don't forget to check our playlists as well. YouTube.com/smashamash/playlists for lots more content. We're also on BitChute. Check that out as we count down to the solstice. We're in the brightest 2 days of the year here, as the solstice occurs tomorrow night at 11:32 and 9 seconds. We'll be streaming live for it, at least on YouTube and on Twitch, possibly on Facebook as well. What are you doing with your final day and a half? What are you doing with your final day and a half of spring? Let us know in the comments. Today we're going to do a cosmology segment. However, it's going to be a separate video, and we'll release that at a later time, as there are some fascinating and exciting stories to talk about once again for our cosmology segment. Next, we're looking at the electron flux around planet Earth. Electrons that surround Earth can cause charging hazards to your satellites, which in turn can cause communications breakdowns. And we're seeing some minor charging hazards here. Internal charging over the southern hemisphere, the Indian Equatorial Ocean, south of the equator, northern Australia, and Oceania, places like Papua New Guinea and so on. Some minor internal charging hazards over those areas because we're seeing high levels of electron flux. So there's the 1-year chart of that. You can see we're way up here right now. And here's the 3-day electron flux chart as measured by the GOES-16. And this is measuring the electron flux at the level of the F ionosphere layer. So while the GOES-16 orbits at like 20,000 miles of altitude, it's a geosynchronous orbit, the GOES-16 is measuring using radiography the ionospheric levels of electrons at about 300 kilometers where the F layer is located. It tells you all about this if you click on details and so on the GOES electron flux page. And we are in electron flux warning levels, so don't be surprised to see communications errors. And if you blame the Chinese and Russians on it, they're experiencing the same errors that you are because they're using satellites as well. So here's the forecast for electron flux. We saw a little lower levels here than forecasted. I won't argue with anything at these levels. I'll just take it as it is. The green boxes are the forecast. The yellow diamonds are the observation. So here's the total electron content forecast showing you electron density, and we see fairly organized blobs of electron density here. A little bit of anomalous GPS errors likely to happen over places like the Caribbean and South America, especially the northern part at nighttime. And this model is actually quite accurate in forecasting GPS errors. I've actually done it myself. Anyway, that's the total electron content. Looking at electron density. So here's a diagram of the Van Allen belts just to give you some context of what you're looking at. And here is the F ionosphere layer animated. You're looking at about a 300 kilometer altitude slice of vibrational frequency. And each one of those blobs represents 1 megahertz, 1 million vibrations per second. And we've been noting some anomalies here over places like South America and the South Pacific. So if you watch this area right here, you'll see some surprisingly high vibrational region there, right there. Those are anomalous ionospheric behaviors, folks. So that is, we've been showing it for the last few days. If you want to see the last couple of days, check out our other videos, youtube.com/smashamash/playlists. The Daily Space Weather has over 700 videos in the playlist. If you want to see what was going on with the ionosphere on a different day, go look at an older video. So yeah, ionosphere once again anomalous. Here's the latest image from 10 o'clock Universal Time. Moving on to our meteorology segment, which we will be streaming live to Twitch. It'll be a separate video from the Daily Space Weather today. Make sure you check that out if you haven't. And we just did our meteorology segment. Make sure you check that out, youtube.com/smashamash/playlists for all of our playlists. Let's get back to bonus features for our Daily Space Weather video. Here comes the hydrogen alpha imagery from El Teide, Spain. And in this imagery, you can see sunspot 2833 here, as well as one of the filaments, significant filament up here in the northern hemisphere. Again, there is a coronal mass ejection watch in the Earth-facing vicinity. Here come some additional bonus features, and they are quite spectacular as always. It's the thematic map of El Sol. It shows you all the features. And there's actually some filaments that are missing here. Now, you know what? These orange areas, that's pretty legit. That's where most of the filaments are. There is one up here that's not showing up as well. So anyway, I like the thematic map. And a great example of how when data goes down and we need new solutions on what to cover, we find this great stuff. Also a crown prominence down here. And by the way, crown prominences are associated with solar maximum. See a little minor crown prominence or two at the South Pole region. Here's the latest intensity gram. Sunspot 2834 is already ready to lose its name. And sunspot 2833 has gained complexity here, so you can see some additional ombre here all around it. That is the kind of thing that happens before major solar flares and coronal mass ejections, folks. So that's a big deal, as we've got some South Pole ombre here and here. That greatly increases the probability of major solar flares and the coronal mass ejection we've been talking about. We'll close out the video with this full disk view and a couple other views. This is 171 angstroms ionized iron from the Solar Dynamics Observatory. Here's 304 angstroms ionized helium. And here's a composite of the two, of just the northern hemisphere where most of the activity seems to be happening right now. In any case, thanks for tuning into the Daily Space Weather. May that solar wind be at your back.